Commutative and associative properties. This lesson in video will be much shorter than the last one you guys had to watch because I'm only doing one lesson instead of combining two. So that's a good thing. So let's start out and let's talk about the commutative and associative properties. So exercise 1, it says add the following numbers without using a calculator. And it gives you a hint, and it says, although order of operations tells us we should add from left to right, let's think of an easier way to sum these numbers. So when I look at that big string of numbers, I say, okay, let's try and find some patterns. So I start out and I say, okay, I kind of see the 3 plus the 7, because that gives us 10, plus, oh, I see another group of 10, 9 plus 1. And then I see another group of 10, 2 plus 8. And to finish it off, I do see another group of 10, 4 plus 6. So I have 4 groups of 10, 40. That was pretty quick. Okay, just changing the order of those numbers, changing the groups of those numbers allowed us to add those numbers in a different way and maybe a little bit quicker. So it says addition and multiplication have two very important properties, which I just used in that first example. And they say with very technical names, the associative and commutative properties. So exercise 2, the commutative property of addition. 8 plus 4 gives the same sum as 4 plus 8, both sums 12. Commutative property of multiplication, same idea, changing the order. 6 times 3 gives the same product as 3 times 6, and that product is 18. The associative property of addition changes the groups. So the sum of 3 plus 5 plus 8 gives the same result as the sum of, well, now let's just shift the groups, 3 plus 5 plus 9. Did I say 8 back there? I think I might have. Both sums are equal to 17. Then the associative property of multiplication, again, same idea, changing the groups, but doesn't change the product. 2 times 5 in a group times 7 gives the same result as the product of, put the 2 outside, times 5 times 7. So, and that ends up giving us a product of 70. So associative property changes the groups, commutative property changes the order. Go ahead and flip the page. Okay. So, and right up here, it just kind of summarizes what I just said. The commutative and associative property essentially give us permission to rewrite addition and multiplication problems in different orders than we're normally given. Okay, it says, give an example that shows that subtraction is not commutative. Okay, that's a biggie. Subtraction is not commutative. So if we go and we change the order, so if we started out with something pretty simple, 5 minus 2 equals 3. If we flipped that order, is 2 minus 5 the same difference? It certainly is not. Okay? So subtraction can't flip-flop the order. Even though subtraction is not commutative, we should remember a very important fact about subtraction. It can always be made into the addition of opposites. So we will address that and see what that looks like. Exercise 4 talks about change the following expression involving addition and subtraction into only one, into one only involving addition, and then use commutative and associative properties to quickly determine the value of this expression. So we have that expression written out. So how can I write it differently? So I do know that 7 plus a negative 3 is the same thing as 7 minus 3 plus 8 plus a negative 2 plus a negative 6 and then plus 1 plus 3. Well, where did that plus 3 come from? That negative negative is a positive. So now what could I do with this from here? I could say, I could group them in a different way. 7 plus 8 plus 1 plus 3. Okay, I grouped the positives. 8, 1, 3, plus, now I could group the negatives. Negative 3, negative 2, negative 6. I grouped the negatives, right? So now, taking that and evaluating it, I've got, I know that this is 15, 16, 17, 18, 19, plus, and then I've got negative 5 and negative 6, which is negative 11. 19 plus a negative 11 gives us 8. So using those two properties, shifting some things around, you still get the same value. So we should be able now to extend the commutative and associative properties for numbers we know to numbers we don't know. Again, bringing it to the variables. The variables bring it to the algebra level. So please recall the following quickly. So 5x and 2x, 7x, combining like terms, 7x plus a negative 3x, 4x, a negative 8x plus a negative 2x, negative 10x. Let's take a look at number 6. In the following exercise, we show how two linear expressions are combined using various properties. List what the properties are. So when I look at the initial problem, it says 3x plus 7 in parentheses plus 2x plus 8 equals, and then on the right side, all of a sudden the order has stayed the same, 3x plus 7 plus 2x plus 8, but the parentheses have gone away. Because there is addition involved there. The parentheses aren't necessary. They're just grouping. So we have the associative property at work there. And then I go down from here. I go down to 3x plus 7 plus 2x plus 8 equals. Now they've shifted some things around. The 3x is in front, but the 2x moved up to the sort of second position, plus 7 plus 8. So now they've grouped like terms, so they've changed the order. That's the commutative property. And following it down, and then all of a sudden now we've got some grouping symbols back in there. They grouped the 3x plus 2x, so they're grouping the like terms, plus the 7 plus 8. Again, that is the associative property. And we end up with combining like terms, 3x plus 2x gives me 5x plus 7 plus 8, 15. Combining expressions below, replace subtraction by addition of opposites if needed. 4x plus 6 plus a negative 2x minus 9. So what I like to do here is say 4x plus 6. This right here, a positive and a negative next to each other, just mean a negative 2x minus 9. And then if we were to group them in like terms, 6 minus 9, we end up with 2x plus a negative 3, which is really just 2x minus 3. Looking at B, we could group negative 6x plus 10x plus 9 plus 3, grouping the x's, grouping the constants. We end up with 4x plus 12. Kind of doing a little less in each step. And now if I could just group them in my mind, 4y minus 7y is a negative 3y, and minus 10 minus 3 minus 13. So you end up using those commutative and associative properties just in your mind eventually. That's exactly what you're doing, is you're visualizing it in your head and you're able to combine like terms from there. Let's take a look at number 6. In the following exercise, we show how two linear expressions are combined using various properties. List what the properties are. So when I look at the initial problem, it says 3x plus 7 in parentheses plus 2x plus 8 equals, and then on the right side, all of a sudden the order has stayed the same, 3x plus 7 plus 2x plus 8, but the parentheses have gone away. Because there is addition involved there. The parentheses aren't necessary. They're just grouping. So we have the associative property at work there. And then I go down from here. I go down to 3x plus 7 plus 2x plus 8 equals. Now they've shifted some things around. The 3x is in front, but the 2x moved up to the sort of second position, plus 7 plus 8. So now they've grouped like terms, so they've changed the order. That's the commutative property. And following it down, and then all of a sudden now we've got some grouping symbols back in there. They grouped the 3x plus 2x, so they're grouping the like terms, plus the 7 plus 8. Again, that is the associative property. And we end up with combining like terms, 3x plus 2x gives me 5x plus 7 plus 8, 15. Combining expressions below, replace subtraction by addition of opposites if needed. 4x plus 6 plus a negative 2x minus 9. So what I like to do here is say 4x plus 6. This right here, a positive and a negative next to each other, just mean a negative 2x minus 9. And then if we were to group them in like terms, 6 minus 9, we end up with 2x plus a negative 3, which is really just 2x minus 3. Looking at B, we could group negative 6x plus 10x plus 9 plus 3, grouping the x's, grouping the constants. We end up with 4x plus 12. Kind of doing a little less in each step. And now if I could just group them in my mind, 4y minus 7y is a negative 3y, and minus 10 minus 3 minus 13. So you end up using those commutative and associative properties just in your mind eventually. That's exactly what you're doing, is you're visualizing it in your head and you're able to combine like terms from there.